Hello guys, welcome back to my channel, Canada Knowledge Quest, where we help do justice to problems of mathematics, engineering and general knowledge concepts. Today we're going to be looking at mathematics on a topic, indices. So basically we're going to be looking at what is indices, some laws of indices. So basically indices is simplifying the process of working with powers or numbers of algebraic expressions. Indices is, for example, when a number is expressed in the form, x to the power of y. We call this the base, then we call this the index or power, or we can call it the exponent. So if we have any number raised to the power of y, the number below is the base, while the one above the number is the index or power of exponent. Now, if we have 5 raised to the power of 3, you know that 5 is the base, 3 is the power. So this tells us that we multiply this 5 times the number here, number it raised into. For example, this is 5 raised to the power of 3. So we have the power of 3, so it will be 5 times what? 5. 5 times 5 is 25. 25 times 5 is 125. Another property of indices, property of numbers, is that numbers can be written in indices form, and it can also be written in fractional form. For example, we have 10 raised to power 1 and 10 over 1. They all equals to 10. This is the indices form of writing this integer. This is the fractional form of writing this what? Integer. Then we now talk about the laws of indices. Now, under laws of indices, we have the 3 basic laws which we use, or subsequently we have other laws of up to 7. Now, the first law is the multiplication law. Now, we have that if x to the power of n times x to the power of m, that is, we have x into the power of n plus m. What do we mean? If we have the same basis, if we have same basis, we do what? We add the indexes. As I've told you, the one that is raised to the power, we can call it either raised to the power, the index, or the exponent. Now, if the bases are the same and they are multiplying, those are the two conditions. A, basis must be the same. The basis must be the same. B, they must be multiplying. Now, so these are the conditions for this one to work. Now, as you can see here, you have the same base and they are what? Multiplying. So we do what? We add the powers. For example, if I have 5 raised to the power 2 times 5 raised to the power 1, you can see the bases are the same. And after all, the base is the one below, while the exponent or the power or the index is the one above. So we have the same base now. We can apply this first law, which is called the multiplication law. Now, and I've told you 5 raised to the power 2 means that we'll multiply the base by the number of times of its index. And here we have 2, which is what? 5 times 5. This is the conventional way of doing it, which is what? 25 times what? 5 raised to the power of 1, which is multiply 5 one time, which is into what? 5 times 1. So that will be 25 times 5, which is what? 125. 5. This is the conventional way of doing it. But if we want to apply the indices rule, still the same, which is what? 5 into what? 2 plus 1. Which will give us what? 5. 2 plus 1 is what? 3. And we have seen before, 5 raised to the power 3 is what? 5 times 5 times what? 5, which is what? 125. So we can see we have the same answer. So that is basically what the first law is telling us about. Now, for the second law, which we call the quotient or the division law, it just is the same properties, basically the same properties of the first law, except for the sign in between, which is division sign. For the quotient law, the conditions are the basis must be the same, and the condition for this law to hold must be that they must be dividing. So if the bases are not the same, we cannot apply this law. And if they are not dividing, we can't use this law. So basically, if we have x raised to the power of n divided by x raised to the power of m, it's either we have x n minus m, which is we subtract the indexes or subtract the exponents. I told you before, we call it either indexes or exponents. We subtract the indices, or we can say it's still equivalent to x n over what? X m. Now these are the fundamental laws, but some of these laws are going to be used to derive further laws, which we call some special law. We are going to look into that subsequently. So, for example, if we have 2 raised to power 2 divided by 2 raised to power 3, we can apply the quotient or division law, which is what? 2 into 2 minus 3, which will give us what? 2 raised to power what? Minus 1. Because 2 minus 3 is minus 1. Subsequent law, we're going to establish how we can simplify this further. Because, as I've told before, indices help us simplify ways of solving mathematics or algebraic expressions. It makes it looks more simplified. Now, we'll go to the third law, which we call the what? The power law. Basically, this means it's just multiplication when we're multiplying the indexes. So when we have something like this, x n to the power of m, we have just one base. We can multiply the indexes, which will have x into n multiplied by what? M. So if we have 2 raised to the power 3 or raised to the power 2, we can just say, we take the common base, which is 2, then multiply the powers. 3 times 2 give us 6, which is 2 raised to the power what? 6. If we want to simplify this further, I've told you 2, we multiply by the number of the power it has. Is 2 times 2 times 2 times 2 times 2 times what? 2. So basically this is the power law. So subsequently now we'll be doing what we call the special laws. These are laws derived from these the first 3 basic or fundamental laws. Now these are the special or derived laws in the law 4. So the zero power law is, and subsequently they are derived from this special or derived or the fundamental laws. So if you're still watching up to now, it means you are enjoying the video. Do not forget to subscribe, like, comment, and share to other people so they could benefit from what we're doing here. So this zero power law means that any number raised to the power of 0 is basically 1. So invariably, if we have x raised to the power 0, it must give us 1. How do we get that? We actually got this from the law 2, the division of quotient law. How? We remember that x raised to the power n divided by x raised to the power m is what? X raised to the power n minus m, or we can say x raised to the power n, or x raised to the power what? M, from our law 2, if you can remember. Now, let's say if n equals to what? M. Now I want to derive how we got this expression, So if n equals to m, applying this equation, it means that x into what? M minus what? M. Remember, this is the law from this is the expression from the law 2, which is the quotient law. Now we'll now say if n equals to m. So this n here, we substitute by what? M. We'll have x equals to m minus what? M, which will give us what? M minus m will give us what? 0. We can call this our equation 1. Now, let's use this second expression and substituting n equals to what? M. So we have that x raised to the power m. Remember our n is m, change to m, over what? X over m. And you can remember from basic mathematics, a number divided by itself will give us what? 1. You can call this equation 2. Now, that's what we call equating terms. By equating, because you can see that x0 equals to 1. So we can equate this and this, because this is the same as this, equal to this. So we can now say x0 equal to what? 1. So this is how we got our expression. Now, for the fifth law, which we call the negative power law, as we said earlier, if x is raised to the power of minus a negative index, it will be 1 over that same number, provided x must not be equal to 0. Because if 0 is here, that function is undefined. It's not defined in mathematics. So for us to solve this, we can say this is x raised to the power minus n. If we want to prove this, we can say 1 times this, it's still the same, 1 times any number is the same number, right? So we know 1 is same thing as x equals to 0 from our law 4, remember? Then we say times x raised to the power minus n. We know that x raised to the power 0 is 1. So they are basically the same. We want to arrive somewhere, This, we didn't change this. Now, you remember from your law 1, when we have the same base and they are multiplying, we add the power. So this is basically the same as what? X into what? 0 minus n. Remember? And 0 minus n is what? X into what? Minus n. So we can basically say this is our equation 1. As we have arrived at this, we can now check back from our law 2. We have that, remember this expression. If I say x power 0 divided by x raised to the power n, we know it's basically the same as this from our quotient law. Remember? Because they have the same base and they are dividing. So we take 1 and subtract the power 0 minus n. So we have this is the same. So basically, this is the same as, if you remember, x raised to the power 0 over x raised to the power what? N. You remember? Because it's the same as our law 2. Now, from our law 4, which is the zero power law, remember that x raised to the power 0 equals to what? 1. So we can just substitute this for 1. Substitute this for 1, which is what? 1 over what? X n, which is equals to what? X raised to the power minus n. So we have proved this negative power law. So we'll move to the next law. Now for the next law, which we call the fractional power or root law, if we have something like this. X into 1 over n is the same thing as the nth root of the base. So what does this basically mean? It says that any number raised to the power of 1/n. This is 1/n raised to the power, which is it's above, its index raised to the power of 1/n is equal to the nth root of the same thing. You know, this is called the square root. When I put 3 here, it becomes cube root. If I put 4 here, it becomes the fourth root. But when I have n here, it becomes the nth root. That's what we mean by nth root. So any number raised to the power of 1/n is equal to the nth root of the same thing or the same number. Now, if I have, you remember from this law, we have x raised to power, okay, let's say if I have 2 raised to power 1, or let's say 8 raised to power 1 over 3, what this means is that we take the one below, we put it in the root sign, then put the 8 here, you know. So that means we're taking the cube root of 8. This means that how many times can we multiply, how many numbers can we multiply together to give us 8? It will be 2 times 2 times 2. So this will give us what? 2. Because 2 times 2, 4 times 2 is give us what? 8. In the same way, if we have the law can also be modified by saying, modified with our law, the power law, which is something like 8, 2 over what? 3. In the same way, we put the one below. No, the index is now a fraction, which is 2 over 3. We put the denominator of the fraction in the root place, the base, we put it in the root sign. Then this one at the power, we raise it above. It's just a modification of the law. So we know that the cube root of 8 is 2, then 2 squared is what? 4. So software, we're going to be using these laws to help simplify mathematical and algebraic expressions. You know? So let's go to the last law. Now, for the last law, which is called the same power law, these are as applied to when the bases are not the same. So what we do, for example, as we have here, x n multiplied by y n. The bases are not the same, but the powers are the same. What do we just do? We multiply the base and take one power. So we have x multiplied by y. We combine it and take one power. For example, we have 3 times 2, 3 raised to power 2 times 2 raised to power 1. What do? We multiply the power must be the same. We multiply the bases, 3 times 2, 6. Then you don't have to just take one power because they are the same, which is what? 36. In the same way, if it's dividing, when they have the same power, you just say, for example, we have 3 raised to power 2 divided by 4 raised to power 2. The bases are not the same, but the powers are the same. We use the same power law. You just say 3 over 4 raised to power 2. So, if you enjoy this video, do well to subscribe, share, like, comment, share to your friends. In our next video, we will try to solve some problems on indices using these laws of the right. Solve different problems, complex, simple, and a lot more before we go into logarithms. Thank you. Thanks for watching. Bye.